state assumption, which assumes that the change in rate of concentration of the enzyme-substrate complex is negligible during the reaction. This was one of the assumptions used to derive the Michaelis-Menten equation. You can think of how in Animal Crossing you initially put in a lot of work farming, but then after some time the rate of harvest stays pretty constant. The Michaelis-Menten model can be represented by a graph of the substrate concentration versus reaction rate V, and can be described by the Michaelis-Menten equation. The problem with this equation is that it's not easy to interpret because it's not a linear graph. Similar to the difficult games that you wouldn't necessarily try to play due to the headache it might cause. The Lineweaver-Burke plot is a double reciprocal plot, and its equation can be derived from the Michaelis-Menten equation. Since the graph can be modeled by a linear y equals mx plus b format, it's easier to interpret. You can think of Lineweaver-Burke as the nice simple games you used to play as a child, such as 7-Up and Red Light, Green Light.
Fun fact, there's actually a protein and gene named after Sonic the Hedgehog. It plays a role in regulating vertebral organogenesis. And you would need the hedgehog signaling pathway to be normal in order to play Sonic the Hedgehog, since it is responsible for proper growth in digits and organization of the brain.
The Michaelis constant is defined as the substrate concentration in which the reaction rate is half the maximum. It is the inverse measure of the strength of the enzyme substrate binding, so it can tell you about the affinity. You can think of the attack stat from Pokemon, where high attack means high affinity. Just remember that affinity is inversely related to Km. The turnover number, or kcat, measures the rate of the catalytic process. You can calculate this since kcat equals Vmax over concentration of the enzyme. You can think of the speed stat from Pokemon, where high speed means high turnover number. The ratio of kcat to Km is called the catalytic efficiency and is used to rank enzymes. A better indicator than the attack and speed stats alone would be the overall level of the Pokemon, which you can think of as catalytic efficiency. By the way, this Pikachu is so cute. On a side note to Pokemon and efficiency, someone made an efficiency chart for all the Pokemon types and arranged them in this complicated circular diagram. That's pretty impressive, definitely worthy of an applause and a thumbs up.
Fun fact, there's an actual white dotted red mushroom that the mushroom from Mario is based off of. It is a hallucinogenic that can cause symptoms of macropsia and micropsia, where objects in your environment can appear larger or smaller than normal. These symptoms are also part of Alice in Wonderland syndrome. What was Mario thinking?